And hello, welcome to this video. In this video I want to continue where I left off. So remember we had the picture of our private network A trying to talk to private network B over the internet, right? Over the internet. Okay, internet. So we have routers at the gateway, or acting as the gateway of network A and network B. Remember the IP address I randomly assigned to the routers were 12.1.1.1 or 2.1 for this one, and 12.1.1.1, and the IP address of the computer on network A will be 192.168.76 on network A, and also incidentally we have 192.168.76. It kind of goes off the screen, so okay, yeah, I will just delete this. Let me try again. 192.168.76. Okay, so we are trying to get a package, a network package from network A, this computer 192.168.76 on network A, to 192.168.76 on network B. So remember I was saying that to craft the IP datagram, you need to have the source IP address at 192.168.76, and the destination IP address will be this one, 12.1.1.1. So we already went through how this package sort of has all the information it needs to traverse from this gateway here, 192.168.76, and of course this router here finds that it's finds that this IP address is not on network A. So this computer knows that this IP address is not on network A, so that it says, okay, I'll just send the traffic to the gateway and let the gateway figure things out from there. So the package will travel to the gateway. The gateway will strip off the Ethernet Ethernet capsule. Remember the header where the MAC address of the internet, the MAC address of the source and destination were contained. That one is stripped away, and then the router will encapsulate it in a new Ethernet or whatever package, and then it will send it over to here. Now at this gateway, we will find that the destination IP address is this 12.1.1.1, and the MAC address will be also the MAC address of the router. Now once the package is here, what happens? Okay, how do we know to send it to this IP address? Okay, so I previously said that we needed some extra information. So the information we have here is called the port number, and the port number in network address translation, okay, it will tell us which computer to send the packet to once we reach the public IP address or the gateway. Okay, so this is roughly what happens. Okay, I'm not being super tight on the definitions and anything. I'm very loose on it. So the actual ones, of course, quite more complicated. I'm just oversimplifying things. Okay. So some of the, as usual, I'll go through some of the important websites I want to go through, and here's none other than Wikipedia. Okay, the most reliable source, right? Yeah, of course there are network address translation. You will have a geeks4geeks, network address translation, which you can just take a look at it here, and then you'll know that there's the port number which is being used. Okay, okay, take a look at this one. Network address translation types, we will have this thing called port address translation. This is also known as net overload. In this, many local local or private IP addresses can be translated into a single registered IP address, where registered IP address is also known as the public address. Okay, so you see the public address, public IP address will be the IP address of this router here on the internet, so to speak. It's just a very nebulous or very overarching term. I didn't say which network is which, but yeah, I'll just call it the internet, right? Port numbers are used to distinguish the traffic, i.e. which traffic belongs to which IP address. This is frequently used as the most cost-effective, as thousands of users can be connected to the internet by using only one real global or public IP address. So again, if this computer has this specific IP address, how does this router know to send the packet here? Okay, so we need extra information, which is this port number. And how is this port number used? Okay, so let's excuse me, let's have a few scenarios. Okay, first is this thing called port forwarding. Okay, so let's say this thing comes from port number 80. Let's say this so before we send it to this send the package or packet from computer A to computer B, we need to say that port number, we need to specify a port number, port 80. Okay, for example, this is remember I said port numbers can range from 0 to 65,000 something, right? This is a 16-bit number, and of course not port numbers are like, you know, subsets of IP addresses. They are just a way for us to organize our traffic, and of course a way for us to tell which computer to send all the traffic to. Okay, so let's say just like IP address, we will have a source port and a destination port in our packet. And let's say the source port is 80 and the destination port is also 80. Okay, 80 is a very common port used for HTTP communications, but which is, for unencrypted like web traffic, I think. So the port is just like an IP address. It's another sort of address, just like a MAC address, IP address. A port is also sort of an address which you can send it to. Okay, so it provides a way for us to distinguish traffic. Except all of these port numbers, they will tell you where the traffic is meant to go to usually within the same computer. But for this case, the port number also helps us to tell the router which IP address to send the traffic to. Okay, so we provide a destination port number. Okay, destination port number of 80, right? So when your packet reaches this router here, the router will see, okay, this is the IP address that I have here. Okay, the destination IP address is 12.1.1.1, and the source IP address, because it's been changed over here at the router because of network address translation, will be 12.1.2.1. Okay, so the packet is where it's supposed to be, and the MAC address also checks out. Okay, and then what's next? Okay, we checked out both of these. So the only thing is that, okay, where is this packet supposed to go? So this router here will read this port number. Okay, the router here will read this port number, and usually there will be a pre-configured system, alright, that may be working like so. Okay, the router is here. Okay, the router is here. This is router 12.1.1.1. Okay, and then this is the destination computer, right? Again, 192.168.76. All right, so the port number is here. Port number is given as 80. Okay, 80. Okay, so the router will read 80. Okay, so usually Alright, I mean, one scenario could be this. Every time this router sees the port number 80, no matter from where, it will direct traffic to this computer. Okay, this is one scenario that can happen. So port 80 means I always transfer to this IP address. And then of course, maybe this is another port number 212. I'm just making random port numbers here. They have no real world application or implication. Every time I see this port number 212, I will direct traffic to 192.168.7.8. Okay, so every time a port number of 212 comes, the router will say, hey, the traffic will just go here. I don't excuse me, I don't really care where the traffic's coming from. I just know when I see a destination port of 212, send it to this IP address. And then I don't really care. And then whenever I see a port number of 80 and it arrives at this router, I just send it to 192.168.7.6. So there is a so-called pre-configured way of mapping port numbers to certain IP addresses within the network. This is the most conceptually simple of them, and it is also known as port mapping or port forwarding. Meaning to say, I don't care what the how do you say? I don't really care what where the traffic comes from, as long as I see the port number. For example, this is the Wikipedia one. Okay, if I see a port number of a certain number, I will just send it to this IP address. Okay, if I see a port number of another number, I will send it to another IP address. So this is a very simple way of doing things. Okay, why is this useful? And how would it where would it work? Okay, because this is pretty simple. You see that, okay, so a port number of 80 will go to this fixed IP address. A port number of 90 will go to another IP address. So in real world applications, where does it work usually? So let's say there are a few computers here. One is for maybe cloud storage. Yeah. Second computer here is for mail. Third computer here is for generic website. Okay, so let's do it like that. Okay, so there are different servers doing different purposes. One server will maybe for cloud storage or file transfer. Okay, so usually if we have a port number that is related to cloud storage. Okay, I don't know what port number is specifically related to cloud storage, but if the port number is related to cloud storage, let's say 123, yeah. Okay, the real world one will be different, but okay, if I receive a packet which I need to talk to a computer that does cloud storage for you. Okay, then all the packets related to cloud storage in port number 123 will be sent to the cloud storage server or the cloud storage computer. Okay, if I have emails maybe there's another port number, maybe 456, 456. Okay, again the real world port numbers will be different. Okay, then I'll send it to the server that deals with mail. So any inbox, anything coming into mail retrieval or sending a mail, they will have this port number 456. Okay, then you kind of know this is related to email, so you'll just send it to the computer that deals with storing and sending mail. Okay, so this is what a mail server does. All right, so if a port number it goes to the mail computer, then the router will send it, or if it's a mail related packet, it will send it to the mail computer. Okay. And then if it's just a generic website, usually this is port 80. Okay, this one is, well, because I watch videos and then I kind of know. HTTP is with port 80. HTTPS is, I can't remember what it is, but this is website surfing, if this server is hosting a website, it likely is that the destination port will be port 80. So anything with port 80, the router will know I need to send this this packet to the computer that is hosting a website. So send the package there, and let this computer do the rest. So this is I guess port forwarding is the best for server networks with servers on it. Okay, port forwarding, networks with servers. Okay, this is what we'll see on the Wikipedia page as well. So can't really go that wrong with that. Of course, there are many other examples, and if you're talking about let's say your own PC, right? Your own PC actually doesn't just send requests for mail, it sends requests for generic website, it sends requests for cloud storage, right? So how does it use port numbers to get back the what do you say? Get back the information. I mean, the simplest way, if we don't have so many computers on network A, we can just look at the source port, right? The source port. Okay, so if the source port is 80, destination port is 80, so the computer on network A is sending a package with a destination port 80, and somehow the router B will read the destination port 80 and will send it to this computer here. But this computer will say, okay, I need to craft a message to send it back to 192.168.76 on network A. How do I do that? Okay, so again, let's use a different color, maybe pink, for the return message. So the IP address, the source IP address will be 192.168.76. Okay, and the destination IP address will be this router over here. So this is the source and destination over here, because this is the public IP address. Okay, so and then what is the source and destination port? Okay, again, the source port here, source port is 80 because this is a computer with port 80. So it will say source port 80, destination port 80, something like that, right? So source port 80 will be crafted into the message, and then of course the Ethernet thing underneath will also be taken care of. So you will send it to the gateway, and the gateway will then erase this IP address, and it will say this is the source IP address. So this is what the new IP datagram will look like, with the source and destination IP address, and then you'll send it over the internet here, and then you'll see the source is 80 and the destination port is 80. Okay, source is 80, destination port is 80, and then what does the computer do? What does the router do? At here, the router will read that the destination port is 80. Okay, the destination port is 80, and using this information here, I'll send it back to this computer. Okay, of course, excuse me, I'm oversimplifying things a lot, but that's the generic idea of how port numbers are used to help us, figure out which computer to send our traffic to. Okay, so actually, port numbers are a lot more complicated than this. They are used for other applications as well, not just for this thing called network address translation, but they are used for other purposes as well. So it is actually part of a whole new layer called the transport layer. Okay, but we are not going to talk that much about port numbers for the time being. I'm going to take a break, and I actually want to introduce you to some tools in this video where you can take a look at how your traffic is routed across the internet. Okay, so there are again two tools. So normally I kind of separate in the previous videos I separated the theory from the practical, but in this video I just want to combine it together. It's kind of just more convenient. Yeah. So I think what time is it? It's about 20 minutes in. So let's talk about some tools. For example, traceroute. Okay, so you know, from the last videos, we actually sort of knew that to get from your computer, even to surf for something on google.com or getting your mail or going to YouTube, Vimeo or some other sites, you need to probably direct your traffic across a lot of routers, which I will just use triangles to denote. Alright, before you reach the end server or end computer, you need to actually hop across a lot of routers. So I'm going to use another color, cyan. Okay, so your journey for the packet across the internet actually hops across. It will actually hop across a lot of routers. Now, how do you actually know which routers, or at least what are the IP addresses of these routers which you hop across? Okay, you can use a very interesting tool called traceroute. Okay, traceroute. Okay, this is the Linux one. Or traceRT. Okay, this is for Windows. Okay, then traceroute. Okay, you can search it on geeks4geeks. So this is a command line utility, and what does it do here? It's it will actually tell you the IP addresses of all the routers which you stop by, okay, until you reach your endpoint. So for example, google.com, you can use that. You can use traceroute to trace your packet from the start to the end. Of course, there are sometimes that the packet, like, it doesn't register, it doesn't show the IP address. That's normal. I mean, there are reasons that happens. Just a disclaimer, I'm still learning all this stuff, but I'm presenting it to tighten up my learning and also, share things in a very, hopefully, more simplified manner and a more chill manner compared to the IT professional. Because I'm not IT professional, I'm just learning this stuff, and then I'm just putting it for my own reference, and if you want, for yours as well. Okay, but anyway, so this Linux, Unix, or Apple Mac OS, the command is traceroute. So using traceroute is very simple. Okay, so let me clear this. Okay, so I'm at my desktop now. Okay, at my home folder, and you can just do this traceroute. Okay, you probably have to install traceroute, sudo pacman s traceroute. Okay, so this is for Arch Linux, sudo pacman s traceroute. This is a very interesting tool for you. Okay, you'll probably have to install it separately on your own Linux or Apple or whatever. Windows, usually it comes with it. You don't need to install a new package. Okay, for Windows is a traceRT. Okay, so I can just do traceroute google.com, and let's see what happens. Okay, you will see that, okay, traceroute to google.com, this is the IP address, okay, of google.com. For today anyway, the IP address will change. Just like how MAC addresses, matching MAC addresses to the IP addresses, the thing will change because of this thing called dynamic host configuration protocol. That guy is the parking marshal that will so-called tell the car to park at which parking lot, and that will change. Likewise, matching a domain name to an IP address, it also requires another protocol, and it's called or requires another process, and this is all covered under domain name service, or DNS. Okay, so let's see. So yeah, it's, I think, 12 hops So it goes from the gateway. Okay, this is, I guess, my router gateway. It goes to sonic.net, and then it goes through a bunch of other IP addresses. It looks like all these are sonic.net servers because that's the internet service provider. Okay. And then what? Okay. So yeah, these things are just all the IP addresses of the where you stop over. Okay, not all of them are shown. I'm not 100% sure why. There is a reason, but I'm not clear enough myself to explain that. But this is a way you can see whether yeah, you can see what kind of servers your packet hops across. So what other websites are there? Blocks. No. Let's see. Pexels. Traceroute pexels.com. There you can find a lot of royalty-free images. Again, this one requires less hops. Okay. So this is a very interesting tool you can use to check out which IP addresses you stop by. Okay. Excuse me. So that's all for traceroute. I mean, this is how traceroute works. I'm not going to go too much into detail. So for more in-depth information, you can go and look into the video before. Okay. IT networking crash course. Yeah, this one. Go to this video and then you will see, okay, under traceroute. Yeah, traceroute is about 4 hours 3909 for this video. There may be other videos that talk about traceroute, but for this video, it's from 4 hours 3909. So you can go and check out how traceroute works. It has something to do with the TTL field. It's actually quite interesting, but this is a sort of a geeky knowledge that you may or may not want to have at this point in time. So I'm going to leave it out, okay, for the time being, at least till a later video where concepts are sort of more solidified, or you're more comfortable with these concepts. Okay, so I'm going to stop for now, and I'm going to see you in the next video, if I make it. Yeah, whatever. Okay, bye.